So I'm here on the ANSYS stand, and one of the big challenges that the automotive industry has is with all the new technologies, they don't have enough time to engineer and develop it. So what we're looking at is an opportunity to do simulation. And I'm going to talk to Walt Herm, Vice President of the Americas for ANSYS, who's going to tell me a little bit about the approach that they're taking and some of the projects that they're working on. So Walt, can you please tell me a little bit about ANSYS?
Yeah, so ANSYS, we are the world's leader in simulation, right? So historically, when companies were building products, they'd build physical prototypes of their product, which would be very time-consuming and expensive. And what we've done at ANSYS is we're enabling companies to build their products digitally, right? So they can test millions of variations inside the computer rather than building and testing them in an environment.
And how is simulation in the automotive industry playing out?
Yeah, so simulation is a big piece of automotive today. So we're seeing two major shifts in automotive, right? We've had the combustion engine for over 100 years. And today we have autonomous taking over automotive as well as electrification. So we have these two major shifts going on. And companies don't have the time to test an autonomous vehicle by driving around millions of miles or testing out new electrified powertrain by building and testing multiple powertrains. And so at ANSYS, we have the ability to simulate these autonomous cars and simulate electrified powertrains.
Does simulation have an impact on the bottom line for the automotive industry?
Yeah. So simulation impacts the bottom line because it reduces the cost of physical prototypes. So today there's a great study out by RAND that says it's going to take 275 million fault-free miles to develop an autonomous car. And if you look at the top automotive companies like Aptiv and Google, they're driving a couple million miles a year of physical testing, right? So that's going to take tens or 100 years to validate an autonomous system. And what we've done is we've built a virtual environment that enables them to test these sensors in a virtual environment so that we can reduce those amount of physical miles on the road. Each mile that they drive costs a few dollars, right, to build a car and test it. And when you can do it in a computer simulation, it's much more cost effective for the company.
Can you demonstrate how the simulation works?
Yeah, so let me show you some examples. So what's unique about ANSYS and the rest of the market is we have the ability to simulate a radar, a LiDAR, and a camera from a physics-based perspective. So what that means is we can put the material properties of the scene, we can put the entire environment together, and we can test all of these sensors, right? And we're the only company in the world today that can test all of the sensors for an autonomous system. So let me show you here what that looks like. So this is a virtual environment, and what you see up here on the top left is the camera, this is radar, and this is LiDAR, right? And so we can run a simulation where we're actually testing all of these sensors virtually. And each one of them, we're looking for different failure modes. So today, when a radar interacts with a guardrail, it has trouble picking up a human being, right? And with cameras, some of the cameras have trouble picking up objects inside fog. So we can test all of these different failure modes virtually and see how they perform in a simulation, right? So this not only enables them to design better sensors, but it also enables them to design better perception algorithms and policy software. Because a big part of autonomy is the development of perception algorithms and policy software. And this gives the engineers an environment to do that. So this is the ANSYS simulation environment from a physics-based perspective. But what else I can show you is we're also working with FLIR. FLIR has been historically inside the aerospace and defense industry, and FLIR designs thermal cameras. And their thermal cameras are unique in the fact that they can pick up objects under bad weather conditions, right? So they can pick up a human in the fog, they can pick up a human behind solar glare. And so we're partnering with FLIR to bring their models inside an ANSYS environment. So we're doing this with FLIR. We're also here with AI, which is a LiDAR company. And so we're with many sensor suppliers here at CES. And so this is FLIR's real-time thermal camera. This is the virtual environment that we built with FLIR to test it. And these numbers are just picking up the different reflective material properties inside the scenes. And so what you're seeing here is this is a regular camera at night, and this is a FLIR camera at night. And what it does is, because it's a thermal camera, it can pick up the objects much earlier. So it gives you a lot earlier, the algorithms, a lot earlier recognition of objects at night. So ultimately, you could have, in a lot of the autonomous cars, you'll have 9 to 10 radars, 9 to 10 cameras, thermal cameras, and LiDARs. And so in the environment, we can bring them all together to test together, so that we can have the companies we partner with, their engineers can write new algorithms for those environments. Yeah.
And is there some practical implementations that you can show for me?
Yeah. So over the last year and a half, we were lucky enough to work with the Volkswagen team on the design of their car to race at the Pike Peek Challenge. And in 2019, we were able to do simulations of the battery and the electrified powertrain and optimize the design of the car. And this broke the world record at the Pike Peek Challenge this year for the fastest climb ever. It was over 16 seconds faster than the previous world record. And we were able to optimize the battery and the performance of the race car for the Pike Peek Challenge.
Thanks very much, appreciate it.
Yeah, no problem. Thank you.